Now we have the special connective tissue. Special connective tissue includes the cartilage, bone, blood, and lymph. So if they ask you to list only the special connective tissue types, they're the cartilage, bone, blood, and lymph. Okay? Cartilage tissue, bone tissue, blood tissue, and lymph tissue. The cartilage and bone together form the skeletal connective tissue, or the body skeleton. So the blank and blank form the body skeleton. It's the bone and cartilage. Or you can have like the bone and cartilage form the blank connective tissue. It's the skeletal connective tissue, or the body skeleton. Or you can, for example, have the question give an example, or give one example for each of the following, and a component of the skeletal connective tissue, and it's going to be either bone or cartilage. We're starting with the cartilage. So cartilage tissue is characterized by its solid intercellular substance. So they have a solid intercellular substance, which makes it resistant to pressure and tension. The intercellular substance contains a compound called chondromucin. It also includes very thin white fibers and specialized cells called chondrocytes. Now the chondrocytes mean cartilage cells. And those cartilage cells, or chondrocytes, are located in spaces known as lacunae. So as you can see here, they're located in spaces or like chambers or rooms we call lacunae. And those lacunae are also found in bone tissue, not just in cartilage tissue. Now we can have very important questions about the chondromucin. So this shows up all the time in the exams. Like, what is chondromucin? What is the location? What is the function? Now the location of the chondromucin, it's located between in the intercellular substance of the cartilage. Okay, so it is in the intercellular substance. And the function of chondromucin, it is the substance responsible for the firmness of the cartilage tissue, making it resistant to pressure and tension. Okay, you can also have another very important question, like who's responsible for the firmness of the cartilage tissue, and the answer is chondromucin. You can have a justification question telling you that cartilage tissue is resistant to pressure and tension because the intercellular substance is solid and firm with the help of chondromucin, which makes it resistant to pressure and tension. And definition of chondromucin is also like a previous question here. And we're just going to say it is the structure responsible for the firmness of the cartilage tissue, making it resistant to pressure and tension. It is found in the intercellular substance of the cartilage, along with the thin white fibers and chondrocytes. Of course, the chondrocytes that are located in the lacunae. The cartilage is classified into several types based on the abundance of fibers in its intercellular substance. So, again, based on the abundance of blank, and you write down fibers. It's very possible to ask you about those stuff. So one cartilage type we're going to have is the hyaline cartilage. So the characteristics, features, we're going to say that it is transparent, and they have homogeneous intercellular substance due to that low fiber content. So they have low fiber content. All of these information are important for possibly a definition question, a description or like characteristics / features of the hyaline cartilage, or even in comparison questions telling you to compare the hyaline cartilage with another type of cartilage, for example, the elastic. So all of the descriptions, all of the traits, all of the adjectives that we're giving to the hyaline cartilage is very important to memorize. So this type of cartilage is found in various locations throughout the body, such as the trachea. And the trachea is this part of the body. It's part of the respiratory system. Now, the cartilage may also be classified as white fiber cartilage, in which white fibers are dominant. It is found in structures such as the intervertebral discs between the vertebrae. Finally, cartilage may classify as elastic cartilage, in which elastic or flexible fibers are dominant. It is found in the structures such as the ear pinna. The ear pinna is the external ear. This is basically your external ear that you can touch right now. Okay. The cartilage that you can touch. That's the whole. Basically your ear pinna is made up of cartilage, elastic cartilage. Now, what is the type of tissue in each of the following? Ear pinna is going to be elastic cartilage. Intervertebral disc, it's going to be white fiber cartilage. Very important to know the tissue type in those structures. What is location and function for each of the following? We've already discussed that. What is the location for each of the following? Lacunae. Now, lacunae, as we already said, they are found in the cartilage tissue within the intercellular substance, and they're also found in the bone tissue. Okay, in the bone tissue. It's not only in the cartilage. The chondrocytes, they're found inside the lacunae within the cartilage tissue. Okay, so if they ask you about the location of chondrocyte, you say, okay, you already know it's within the cartilage tissue, but you should mention that it is found inside the lacunae. So the lacunae contain these cartilage cells. Question, what is the function for each of the following? The lacunae. The lacunae, they serve as small spaces, or small rooms, or small chambers, or cavities that house the chondrocytes, plus the osteocytes, the bone cells. And the function of chondrocytes, they're specialized cells, and they're responsible for maintaining and secreting the components of the cartilage matrix, including the chondromucin and fibers. So the chondromucin and the fibers are secreted from the chondrocytes. It's possible that you can get a question about this. Question, how do you microscopically differentiate between tracheal cartilage and ear pinna cartilage? This is an important question. We know that the ear pinna cartilage is elastic cartilage and the tracheal cartilage is hyaline cartilage. So we're going to compare the elastic with the hyaline. The elastic should be yellow in color due to the presence of elastic fibers in the intercellular substance. Meanwhile, the tracheal cartilage or the hyaline cartilage should be transparent due to the low white fiber content, so that the intercellular substance is transparent and homogeneous. The bone is the connective tissue that is harder than the cartilage tissue due to its intercellular substance containing high concentrations of inorganic calcium salts such as calcium phosphate and calcium carbonate, along with white fibers. So here we can have a very important justify question or explain question, telling you that the bone tissue is characterized by its firmness or hardness, or telling you to justify that the bone tissue is harder than the cartilage tissue. And the answer, due to its intercellular substance containing high concentrations of inorganic calcium salts, such as calcium phosphate and calcium carbonate, along with white fibers. Okay, this is the answer. You can also have possibly a question telling you to give an example for each of the following, and a calcium salts or calcium salts, and they're the calcium phosphate or calcium carbonate, or telling you to give an example of inorganic salts and the same thing, calcium phosphate or calcium carbonate. So there are two types of bone tissue. We have compact bone and spongy bone. And like cartilage tissue, bone tissue is composed of specialized cells called osteocytes. So the osteocytes are the bone cells, similar to chondrocytes being the cartilage cells. And these osteocytes are also located within lacunae, so similar to the chondrocytes. The bone tissue also contains microscopic white fibers and an intracellular substance. If we closely examine a section of compact bone, we observe that its intercellular substance is organized into structures called bone lamellae. Let's look at the picture here. So these are the bone lamellae we can see. So these are called concentric bone lamellae. Now, concentric means circles or layers that share the same center. So if we can see each bone lamellae here, or each bone lamella, is like forming a ring-like structure, and they all share a common center. Okay, so we have 1, 2, 3, 4, and they all share a common center, similar to like a bullseye or like ripples in water. So these are what we call concentric bone lamellae. So they're layers. But this is not the only type of lamella we have. So some of those lamellae are arranged parallel to the outer and inner surfaces of the bone, and they're known as the peripheral lamellae. But the others are arranged concentrically, as I said, concentric bone lamellae, like around a central canal, and this canal is called the haversian canal, through which blood vessels and nerves pass. So the haversian canal allow the passage of blood vessels and nerves. The concentric bone lamellae surrounding the haversian canal form a structural unit called the haversian system. These haversian canals are interconnected by transverse canals known as Volkmann's canals. Now, we can have a very important question. They're telling you that concentric bone lamellae surround a central canal called blank and constitute a system called blank. So the central canal is called the haversian canal, and the system they form together is called haversian system. So haversian system equals to haversian canal plus concentric bone lamellae. And as we said, the haversian canals are interconnected by transverse canals known as Volkmann's canals. There are also intercellular lamellae, we call them interstitial lamellae, that fills the spaces between the haversian systems and the bone's peripheral lamellae. So this is the location of the interstitial lamellae. Spongy bone tissue differs from compact bone tissue in that its bone lamellae are not arranged in the same organized manner. Instead, they form irregular trabeculae. Now, trabeculae are like irregular branching networks of bone that is characteristic of the spongy bone. Instead of solid rings that we've discussed in the bone lamellae here in the compact bone, we said that they look like a ring. They look like onion rings even, like you can imagine it being an onion. This is how the onion looks like. But here in the trabeculae of the spongy bone, we don't have this organization. We don't have this uniqueness, neatness of the compact bone. In fact, they're irregular. They're like a mesh structure or lattice structure that is actually strong but like lightweight. So they say that the irregular trabeculae branch and reconnect, creating vacant spaces filled with bone marrow. So they form spaces, and these spaces will get filled with bone marrow. You can have definition questions, either the Haversian canal or Volkmann's canal. The Haversian canal, we're going to say there are central canals located at the center of the concentric bone lamellae and compact bone. Blood vessels and nerves that supply the bone pass through it, and these canals are interconnected by transverse canals known as Volkmann's canals. Volkmann's canal's definition: there are transverse canals found in the compact bone and connect adjacent Haversian canals to each other. You can possibly have the questions location function of the Volkmann's canals. So as we said, the location is in the intercellular substance of compact bone between the Haversian canals, and the function that they connect those Haversian canals to each other. Justify the presence of Haversian canals and Volkmann's canals in the bone. This is actually a real question. And the answer is Haversian canals allow blood vessels and nerves that supply the bone to pass through it, and Volkmann's canals connect the adjacent Haversian canals to each other. So here, we're just mentioning the functions of the canals. Okay, this is the justification of their presence. The comparison question between the bone and cartilage is very important. We've already discussed everything. We said that we have two types of bones. Here we have compact bone, spongy bone, but here we have three types of cartilage. We have hyaline, white fibrocartilage, and elastic. And we're going to make a comparison point being that chondrocyte contains chondromucin, but the bone does not contain chondromucin. Instead, we can say they contain the inorganic salts, like the calcium phosphate, calcium carbonate. And of course, we're gonna just talk about the introduction. So bone is a connective tissue that is harder, and here it is not as hard as the bone, so it's like less hard than the bone, and contains white fibers and elastic fibers. But here we say that it is harder due to its intersubstance containing high concentration inorganic calcium salts, and of course the white fibers also being responsible for the hardness. Another very important question is the comparison between the compact bone and the spongy bone. We said the spongy bone is less hard than the compact bone, the compact bone being harder than the spongy bone. And the intercellular substance is organized into structures called bone lamellae, arranged in three different ways. The arrangements are like peripheral lamellae, concentric bone lamellae, and the interstitial or the intercellular lamellae. But in the spongy bone, the intercellular lamellae are not arranged in the same organized manner of compact bone. We said that they're irregular trabeculae that branch and reconnect, and they create vacant spaces filled with bone marrow. Here, of course, they contain Haversian canals, and the purpose of Haversian canals is that they allow the passage of the blood vessels and nerves that supply the bone, and they of course contain the Volkmann's canal to connect the adjacent Haversian canals to each other. But here they do not contain, or the spongy bone does not contain the Haversian and Volkmann's canals. And here we're gonna make another comparison point, is that they contain Haversian system, but the spongy bone does not contain Haversian system, which is very easy.